everyone, how's it going? Let's make this. So go into Google, type in Google Colab, and it'll open up this link for you, Colab Research Google. So go ahead and click this. It'll take you to one of these pages. Under the file, just open a new notebook, and it'll come you and bring it to you to this particular page here. So go into runtime. The first thing you want to do is make sure we are running under GPU, and it will be selected as none by default, but make sure you're doing GPU and then just save. And it'll create a new environment for us with the GPU. Now, the first thing we were going to be doing is installing all the dependencies and libraries that we need for this project. So pip install and all the applications that we need. So this will be the first line that I'll put in the description. These are a couple of Torch libraries that we need, and I will just copy and paste it here. This whole line will be there in the description. This will be the first step you're going to be installing, and just make sure you're taking care of everything. The next step is installing the MMCV, which is the MMDetection library that we are going to be using. So pip install MMCV full. So it's going to be installing all the dependencies using the CUDA operators. And now we're going to be cloning a new repository. I'll show you what repository we're going to be looking. Let me open up here and bring this particular page here. So this MMDetection, which is through the MMLab, this is what we are going to be using. And we are basically just cloning this repository. And if you want, you can just copy this, or I'll put it in the description to make it easy for you. What you're doing is just git clone this repository, and it'll clone the repository for us. You are then going to be changing the directory, or maybe for now at this stage, let's just run this to make things easy for us. So it's installing all the PyTorch versions that we need for this application. It's going to install MMCV and then take care of the MMDetection. We'll give it a few seconds to run, and then I'll come back and continue from here. So once we have done with this, you can open up this folder here, and this directory, there is this MMDetection folder. If you click on this, it'll show you all these files that were cloned from the repository. So let's close this back again and go back to what we were doing. So let's come down to this directory, which is the MMDetection directory. So we say cd or change directory to MMDetection. So it'll take us to the MMDetection folder. And you can see now we are inside the MMDetection folder. This MMDetection folder comes with its own requirements, own build files that it's required for running this. So we will use pip to install these. For that purpose, now normally what we do is we do pip install MMCV, Torch, or whatever pip install you're trying to do. It downloads it from the pypy.org website. But in this case, we are trying to install it from the MMDetection folder. So for that purpose, there is a special command which says pip install -e and with a full stop. So it will go ahead and install whatever requirements are needed in this particular directory. So it'll take care of that. And there is one more thing, which is basically pillow. And pillow is going to be used for displaying these images in our browser. So pip install pillow, and we will install version 7.0.0. The reason for this particular version is just because to have compatibility with Colab and the other files that we are using here. Now let's go ahead and run this. So it will take a few seconds, and it will install all the directories or all the libraries that is required. So you can see matplotlib, numpy, 6, pycontrols, kiwisolver. I'm not sure most of these, I don't know what even most of these require, but it's installing all of this for us, and it is giving this restart runtime. So the moment you do restart runtime, it takes us back to this directory here. So we came back out of MMDetection. It did restart everything for us, but the libraries and the dependencies that we had installed, it still continues to stay with Colab. So with that, now we come down to the main coding part. So the next step would be to download the weights file, the checkpoint or the weights file that we need for this particular program. So we'll say create a directory for us called checkpoints, where we are going to be downloading some weight files. So we'll say checkpoints or mkdir. So make a directory called checkpoints. So if we run this, you will see there is a new folder. If I refresh this, there's a new folder called checkpoints created for us. Now the next step is to download certain weight files. Now there is another link in the description which you can copy and then come here and just paste it. So it's going to download this particular file, which is the mask rcnn r50 cafe net, and this is the whole weights file which is going to be used by this MMDetection. So just run this and it will take a few seconds, few minutes, and then download the file into this checkpoints folder for us. Good job. And then now, while this is being done, we will start initializing the checkpoints and the configuration files that we need for this AI. Come back here, create a new code file, and then now let's start importing and let's start using the libraries. So you can see that it has downloaded. It might show up here, it might not show, depending on the size of the file, but nevertheless, it is going to be downloaded in this checkpoints folder. Now come down here. So let's start importing the libraries that we need. So we have the MMDetection, MMDet, and it has certain APIs that we can use. The first API we're going to be importing is the inference detector, which goes by this inference detector, and then init detection or initializing detection, init detector, and then show result pyplot. This will allow us to show the image or the detected image in the browser for us. Now, next step would be to initialize or find out the config file. There's a config file here. If you go into the MMDetection folder, under the configurations folder, the configs folder, then here, these are all the different types of configurations that you can use. You can recognize the fast RCNN, which we used in some of our older videos, the InstaBoot. So there are a couple of other mask RCNN. So there are quite a bit of configurations that we can use. For the purpose of this particular project, we're going to be using the mask RCNN, and under mask RCNN, there is this particular one which says R50, and then under R50, you're going to cafe FNN MS train poly 3x coco. So this particular file, you're just copying the path so we can tell where this particular file is. So just come down here under the mask RCNN folder, and this particular file R50 cafe FPN 3x coco pi. And you're initializing, you're saying the configuration that we're going to be using is this particular config file, and just copy the path that we did and then paste it here by pressing Ctrl V, and it will then just initialize where the configuration file is. The next thing is the checkpoint file. So the checkpoint is given by this particular file, which is present in the checkpoints folder. So we downloaded in this checkpoints folder. We just copy this line here. It's under the checkpoints. So we say, and then initialize it as a string and then paste it here. So we are saying the checkpoint is present in this particular folder and the configuration file is present in this particular folder. Good. Next step is to initialize the model that we will be using. So for that purpose, we say model equal to init detector and bracket, and it takes a few arguments. One argument is the config, the second argument is the checkpoint, and the third argument is the CUDA or the GPU version that we are using. And in our case, we used CUDA, which goes by under a string, CUDA :0. Then you're just specifying the GPU version that we have. With that, just run this and it will initialize the detector for us. You can see use load from local loader. So this is now initialized for us. So the first step would be to test out this simple. So all the heavy lifting so far has been done. Come down here. Let's close this configs folder, and there is this demo folder that we can use, and it has certain images and it has certain files or videos that we can test. This demo.jpg, let's run this. So we can copy the file path and we'll try to do some image detection on this demo.jpg. So you can say that I have an image in this directory and it is present in this particular location, which is given by content MMDetection demo.demo.jpg. We just control V, pasting the file path that we copied from here. Next step is we are going to be saving this or showing the result, and it is in this particular folder called result equal to inference detector using the model that we initialized in the previous step and the image that we supplied. So please go ahead and do some inference detection or segmentation for us, and then store it in this particular variable called result. It will run through, and it says that there is an error. It says the content or demo JPEG is not available. So let's see why this particular file is having an issue. And you can see there is a space that I could put down by mistakenly, and that's the reason it's causing this. So we just remove the space and try to run this again, and it should hopefully detect the image for us. You can see that it completed without any errors. Good. So now let's use this result and display it in the browser for us. So we will use this show result pyplot function. We'll say show result pyplot model comma image, the img, the result, and a score threshold of 0.3, which is given by score threshold 0.3. And if we run this, it should create a pie plot or an image for us here in the browser. So you can see that it's neatly doing this image segmentation, detecting what the object is, the cars behind. Even though there are trees, it can still see the car behind it. And it's a pretty neat detection or image segmentation module. So that's all with the images. Now, how would you do that if you were to run through videos or webcams? For this particular purpose, since we're using a Colab to utilize the GPUs that Colab provides, we will be doing the video demo, but you can also use a webcam demo if you were to do it in real time. But of course, you do need the GPU to run image segmentation of this level and in real time. So we'll go into the video demo and we'll try to run it on a video file. There's a video file present here, demo.mp4. We will use this for our purpose, but you can also download or upload your own video. For that purpose, you can create or come down here to the demo folder, click on this and upload. So if you press upload, it'll allow you to upload any file or any video that you want to test for this particular project. So upload the video, and then like I am doing for demo.mp4, the first step is to create a new code file, and we're going to create, or we're going to be calling this video demo.py. Let's copy the path file for this one, copy path, and we'll use Python to run this, control V. So we're going to say Python, please go ahead and run this MMDetection video demo.py file. But this file does not run by itself. It needs some arguments. The first argument is the video that we want to be running. So this demo.mp4, come down here, copy path, and paste the file path for the video. Put this inverted slash. Now the next thing is specifying where the configuration file is. Go back here, go into the configs folder, mask rcnn, which is right down here. Then this particular file where it says 3x cocoa pie, come here, copy path, and then come back here. Just press this, and it is now using the file that we need for configuration. Then third argument is the checkpoint that we need. So let me close this back again, come back here. This particular checkpoints that we need, that we copied here. So we'll just copy this, come here, and then paste. So it's going to now use the checkpoints that we have. The last argument is the output file. So what's the output file going to be look like? So that goes by -- result.mp4. So it's going to then store the result into this result.mp4 folder. So let's close all of this back again and keep a clean directory for us. And let's run this. So it'll take a few minutes and it'll go through each frame in the video and then create an image segmentation output for us. So you can see that it found out about 67 frames in this particular video, and the video should be available in a few minutes right here in this particular directory by the word result.mp4. In fact, if we refresh this, you can see that a new file result.mp4 is created. It's still under construction because it's going through this, but after a few minutes, this file will be ready for us to run. All right, so it looks like it's all done, and you can see there is a result.mp4 file which is available for us. In order to play this, you can double click on this file or come down here, just press download, and it will download the file for us. Yeah, so that's about it. So this is for video detection. Similarly, there is another file here that we saw for webcam demo, which is called by webcam demo. And this particular file here will allow us to run a webcam in basically the way you want. It takes a certain arguments. Again, it's going to take the configuration file, the checkpoint file, the device that we're going to be using, the camera ID. 0 is the default, and then the score threshold is 0.5 for this purpose. And it will then start running the webcam demo in real time for you. With that, you guys take care, stay safe, bye-bye.